In this video, we are going to do these 8 questions from the chapter limits, and they are all based on trigonometric identities. As you can see, including we'll be applying C and D over here. Then we'll be applying 1 minus cos 2x in these questions to write in 2 sine square x over 2. And else we can see that we'll be applying a sandwich formula, that is sine x over x for limit x tends to 0 is equal to 1. So let's begin with the first question. In this question, we have to evaluate this trigonometric function and for the limit x tending to 0. So we are going to use the trigonometric ratios. First of all, I will write tan x, like we have an x, and tan x can be written as what? Sin x over cos x. Further, you know that we can write 1 minus cos 2x as what? 2 sine square x. Using half angle property, this is 2 times sine square x is equal to limit x tends to 0. This is x sine x over cos x. Now I can divide this. Dividing is same as multiplying with the reciprocal, so it will result to give you 2 sine square x. Now we can figure out that one sine get cancelled. So what we are left with, this is limit x tending to 0, x in the numerator, and that divided by, this is 2 sine x dot cos x. I can write this as 2 sine x cos x. So limit x tends to 0, we have an x, and this can be written as what? Sine 2x. This is sine 2x. Now I can multiply and divide it by 2. Let's say in the next step, I write this 2 outside. So it will be what? Half, and limit x tends to 0. This should result to give 2x over sine 2x. Now check for this part, we can write 1 right from here. So 2 half multiplied by 1 is half. So we'll say that half is the answer for this question. The question is to evaluate this trigonometric function for limit x tends to 0. Now from the question, it is very clear that we are going to apply sine c minus sine d identity in the numerator. So let's begin with that. We have a limit here, x tends to 0. This is limit x tends to 0, applying c and d, that is sine c minus sine d is what? 2 cos c plus d by 2. So it's 2 cos c plus d by 2 into sine c minus d by 2. So it's sine c minus d, that is 5x minus 3x by 2. And that whole divided by what? We have in the denominator as sine x. Now, after simplification, what we are going to get here is limit x tends to 0. This is 2 cos 5x plus 3x is 8x over 2 is what? 4x. One more time. 5 plus 3 is 8 divided by 2 is 4. So that's why it's 4x. That multiplied by sine. This is 5x minus 3x is what? 2x. 5x, 5 minus 3 is 2. That divided by 2. 2 divided by 2 is 1. And over sine x. Yeah, what we can figure out there, that this sine x get cancelled. So we are left with limit x tending to 0, 2 times cos 4x. And placing the limit, we get 2 cos 0. And what is cos 0? Cos 0 is 1, right? So therefore 2 is the answer for this question. In the next question, we have to evaluate this trigonometric function for limit x tends to 0. And as you can see, I've written some formulas over here. We are going to split 1 minus cos 2x. We are going to apply this identity as 1 minus cos 2x, 2 sine square x over 2. And in the denominator, we'll be applying cos c minus cos d. Let's begin with the first step over here. We have limit x tending to 0. As I said, a numerator can be written as what? 2 sine square x. And the denominator, it is what? Minus 2 sine c plus d over 2. So what is c plus d? 2x plus 8x, that is 10x. 10x over 2 is what? 5x. multiplied by c minus d. So c minus d. So 2x minus 8x is what? 6x. 6x over 2, that is 3x. Then this is sine minus 3x, in fact. Now what we know that this 2 can get cancelled, and you should also remember that sine of minus x. Sine minus x is minus sine x. So if I write this as minus 3x, that will influence this sign and will become positive. So let's write down this is equal to limit x tending to 0. We have sine square x, that divided by, as I said, this minus and this minus will make it positive. So we'll get positive sine 5x dot sine 3x. Now next, to apply the sandwich formula, for that what you can see, this is limit x tends to 0. We have sine square x. So I need to divide it by, so I divide it by x square, but then I have to multiply by x square. So I can write x square as what? X into x is what? X square. Now check for the other part. In the denominator, we have sine 5x. So I wrote sine 5x over here and sine 3x. Now you can see that we need a 3 over here. So I multiplied by 3 and I divided by 3. Right, let me show you properly. So I'm multiplying and dividing by 3 here. And for this, I'm multiplying and dividing by 5. Now check what we get. This 5 and 3 can be written outside the limits, that is 15. So I'm writing 1 over 15. And what else? We have limit x tending to 0. So what you can write this as? We can write this part as what? 1. 1 square is 1 multiplied by. What about this? This is, I'm talking about after taking out 5 common. This can be written as what? Including this 5x. Right. So including this is 5x over, this is 5x over sine 5x. So that will give you 1. And then like this way, we can apply the sandwich formula over here also and write this as 1 again. So check here, this is 1. So we had 1 over 15 and that multiplied by 1 should give you how much? 1 over 15 is the answer for this. So this is equal to 1 over 15. Similar to the previous question, here too also we'll be writing cos 3x minus cos x by applying the identity of cos c minus cos d as this. So let's begin with this only. So we have a limit x tending to 0. Let sine 2x be as it is. And I'm going to apply the identity of sine c minus sine d, which is minus 2 sine. So I'll write minus outside, minus 2 sine c plus d by 2. So 3x plus x, what is that? 4x by 2 is 2x, right? And then similarly sine c minus d. So 3x minus x. 3x minus x is 2x divided by 2 is x. So we have sine x over here and then whole divided by x cube. Now this is minus 2, I can write outside the limit. So I should write minus 2 outside the limit. So this is minus 2 written and then limit x tending to 0. This is what? Sine 2x and then sine 2x again. I'm not multiplying them. And this is sine x. So we have x cube. I can write each x in the denominators of each of these. So now what you can see that we need a 2 over here. So I'll multiply and divide it by 2. I'll multiply and divide it by 2. Check here. Now look into the numerator. So we have 2 into 2, 4, and there is another 2 over here. So that comes out to be minus 8. Minus 8. Then proceeding with this is limit x tending to 0. So what you can write this part as, this should give you what? Applying the sandwich formula should give you how much? 1, right? Similarly, applying the formula, we can write this as well as 1 and this 2 also as 1. So that will give you, and these two are taken out already outside. So we can say that this is, over here it is 1 into 1 into 1. So therefore minus 8 is the answer. Minus 8 is the answer for this question. For this question, to evaluate this trigonometric function, we are going to apply 1 minus cos 2a. So it is 2 sine square a. So if I solve this time the limit is theta tending to 0. So what we can write as 1 minus cos 4 theta as, so it should be 2 sine square. We are applying half angle property. So 4 theta will become 2 theta. So 2 square, right, 2 sine square 2 theta. And likewise below I can write 1 minus cos theta as 2 sine square half angle property, that is 3 theta. So here 2 and 2 get cancelled. So now we have limit x tending to 0. So this is sine square 2 theta and this is 2 theta. What in case if I divide by 2 theta whole square, right? So dividing by 2 theta whole square is what? Actually dividing by 4 theta whole square. 2 theta whole square is 4 theta square, that is. So I should multiply by 4 theta square. I'm going to multiply and divide. Let me show you properly. What I'm actually doing is I'm dividing and multiplying. So this is actually 2 theta whole square and then I should multiply this by, this is actually 4 theta square. Now we have below as what? Below as what? This is sine square 3 theta. Now check here, this is sine square 3 theta. So I need a 3 theta over here. So I'll write 3 theta square, right? And then also I have to divide it. So this is actually what? This is 9 theta square. Now next is to rearrange them. Before that, we can see that this theta square and theta square get cancelled. So 4 over 9, this 4 and 9 are left. So we can write this outside the limit. So this is equal to 4 over 9 outside the limit. And then we have limit x tending to 0. This can be written as what? Sine 2 theta over 2 theta whole square. And similarly, the remaining part can be written as 3 theta over sine 3 theta whole square. So using this sandwich formula, what we can write? These can be written as 1. So this is going to be 1 and this is going to be 1. 1 square is 1. And that's why we'll say that this will give you 4 over 9 multiplied by 1 into 1. So that is 4 over 9 into 1 into 1. So that is 4 by 9 is the answer for this question. Now this question of trigonometric function, we have to evaluate the limit. So what we are going to do is to divide the numerator and denominator each term by sine. So let's say if I write this as what? This is limit x tending to 0. Since I am dividing the numerator by x, so it says each term is divided by x, and same I'm doing with the denominator. So denominator is what? 4x over x plus sine 2x over x, right? Now, next what I'll do here over here is to, we need a 3 over here. That's why I multiplied it divided by 3. For this part, I need a 2, so I multiplied divided by 2. Further, you can also see that this x and x can be cancelled. These x are also cancelled. Now, applying the limit for each part, let's say I apply the limit for this part. This is going to be what? Limit x tending to 0, right? This is 3, I can write outside this 3. And then we have sine 3x over 3x. Plus, this is independent of x, so we'll not apply limit over here. Coming to the denominator part, this is independent of x. So we'll be simply writing 4 over here. Plus, we'll be applying limit over here. After writing 2, 2 is outside the limit. Limit x tending to 0. X tending to 0. This is limit over here. That is sine 2x over 2x. Now check what we are getting. We are getting a 3 over here. From here it is 3. Now applying the formula of standard limits, that is this one, we'll get 1 over here, right? So this results to give you 1 plus 7. And similarly, we have 4 plus 2 multiplied. This is 2 multiplied. And then applying limit once again over here, the standard limit, we are going to get as 1. So this is 2 into 1. So finally, so what we get the numerator, that is 3 plus 7, that is 10. And this is 4 plus 2, that is 6. So it can be reduced. So this is 5 over 3. Yes, so 5 over 3 is the answer for this question. Now it's very obvious by looking into the question that over here 1 minus cos 2x will be applying this identity, that is 2 sine square x over 2, and we can write tan as sine over cos. It is possible to write the direct identity. Let's proceed with the question and then we will decide. So this is limit x tending to 0. What is 1 minus cos 2x can be written as, that is 2 sine square x. And there is a 3 over here. What I can do, I can write tan square x as sine square x, right, divided by cos square x. Let's understand what I'm doing here. I'm writing tan as sine over cos. So I can write this as sine square x divided is same as writing as cos square x over here. Right. So you can see that over here this get cancelled. So 2 over 3, which is can be written outside the limit, we are left with limit x tending to 0 cos square x. And by placing the limit, what we are going to get, cos 0 is what? 0, right? Cos 0 is 1, sorry. Cos 0 is 1, so it will give you 1. So 2 over 3. This would be the shortest way of doing this question, I suppose. Now in this question, by looking into this, we are very clear that we are going to apply this identity, that is sin x over x is equal to 1. So let's figure out how we do this. So this will limit x tends to 0. This is sine square 4x square. So I can write 4x square as what? I can write this as 2x whole square, right? Below also we need 2x whole square. So what I'm writing 2x square whole square, right? Because it is x raised to the power 4. So at the end, we actually divided by 2 raised to the power 4, right? We actually divided 2 raised to the power 4. So therefore, I should multiply with 2 raised to the power 4. This is how much? This is 16. So I can write this outside the limit. This is 16. And what we have, that is limit x tending to 0. Now I'm making some changes over here. Let's figure out. I'm putting y is equal to 2x. So first of all, 4 is outside and the limit has changed, right? But then you have to also mention in the exam that y tending to 0 as x tends to 0. Now check here. We have changed the limit. Now it is y tend to 0. This is sine square, right? What we can do here, that instead of this, let's take 2x whole square, right? So this is going to be, you can see from here, I have taken this 2x square as y. So it's become 2 square y. This whole thing I have taken as y. And that divided by this whole thing is y, right? This whole thing is y. We replaced with y. So it results to give you how much? I need to show it again because it seems to be complicated. I've taken this whole thing as y. All right. So this becomes, below it is y square. And we had a 2 raised to the power 4, that is 16 here. Now just look into this part. That means if I write 16 outside, this is limit y tending to 0. This is sine y over y whole square. And therefore we get 16 into 1, that is 16 is the answer for this question.